Sweet, what the hell are you doing? Get back in the lab. Greetings, Astro the audio guy here yet again on this 4-channel mixer preamp project that I have been toiling away at over the last, couple of days. And today we're going to be looking at the next stage of the design, which is doing the back handle. For some reason I keep saying band axle. I have no idea why. I mean, both are correct, but it just sounds totally wrong when you say it as band axle. Anyhow, semantics aside, I'm going to be looking at the back handle circuit and the output stage that is going to be needed for this preamp to work. And my whole entire goal here is to design this as 2 modules. The first module is going to be the input circuitry side with the 4-channel mixing, well, the 4-channel inputs, and the 47k mixing resistors on each of the outputs. And then the second module is going to be the tone control stage, which will also feature the summing amplifier on that board, and there's a reason for that, plus the output stage. Now, the reason for having the summing amplifier, the tone amp and the output amp on a separate PCB is so you could join, say, another 4 channels to that mixer board, basically. So that means you could expand it from 4 channels to 8 channels just by simply putting one link wire in between the 2 input boards to join the 47k resistors together at one point before going into the mixer. And you end up with 8 channels. That's the idea that I've got in the back of my mind, but that's not really relevant to the topic of this video. So basically here is a block diagram from the last video, and all it's been added to it is the extension circuitry needed. Here I've represented the back handle circuit as just the bass, mid, treble with a op amp there in the feedback path. Then goes into a master volume control, finally into the output buffer. Now, with this output buffer, remember we've got an inverting amplifier here and an inverting amplifier there. So that means that the signal will be the 0 degrees out of phase before it enters the summing amplifier. It's going to be 180 out of phase when it leaves the summing amplifier. And it's also going to be another 180 degrees out of phase when it leaves the back handle circuit, which means it'll now be back in phase with the original input. Now, this is not really that important if you're just going straight into a power amp. However, if you're going into a line out and then going into another device, if, say, this is out of phase, 180 degrees out of phase, with whatever this is, and you take your output off before the master control to another, say, preamp or something, well, if we're the correct phase here, going out into the other preamp or power amp, and we're 180 degrees if we used a inverting amp here as the output buffer like you would normally do, well, if this was going into a power amp and that separate line out was going into a power amp, and they were driving a speaker each, what would happen is you would start losing bass and mid-bass frequencies because the 2 signals are out of phase with each other. Therefore, they're going to start cancelling each other. And then you'll end up with a lack of bass and wonder why. So that is the very big reason why here I've got to be super careful what type of amplifier I use as a buffer, because I probably in the end will have a line out coming before the master volume control into a separate buffer maybe. And that's another thing. If you're going to use another buffer here for the line out, well, that can be the same phase as this. So if this was 180 out, as long as that was 180 out, it wouldn't matter. But that's basically what I'm going to be concentrating myself on with today, is this section. Now with the back sandal circuit, I'm not going to build the whole entire thing, because I've built this thing several hundred times before with the same component values in the past, and it works absolutely fine. The Class D amplifier uses exactly the same circuit, so I don't need to reinvent the wheel basically and test stuff again unnecessarily. So for this, I could just simply have a inverting amplifier with unity gain just to pass the signal from here to there, or I could just build up the bass circuitry with that amplifier in the circuit just so I can vary the bass. I could do that, or the mid, not much point to that, or maybe even the treble. Still not much real point to it, but I might just do the bass so we've got some form of active control there. That's going to be fed into our master control, into the output buffer, which I am going to be using a non-inverting amplifier for that. So we need to look at some schematic drawings on paper to see where I'm going. Alright, so that's probably the best I can do in this situation to show you the schematic. Now, our input comes in over here from our summing amplifier, going into this back sandal circuit featuring a inverting op amp. That 39 picofarad there is to stop this from oscillating or going into oscillation. Output comes over this side, which is on the output pin of this IC, through this 1 microfarad, again because I've got stacks of them, blocking capacitor, and through this 100 ohm resistor. Now what this does is, when you're interconnecting op amp stages together, it's always a good idea to use what's known as a bypassing resistor, which is what this is. And all that does is it stops the high gain next stage from causing the either high gain or lower gain op amp stage before it from going into oscillation, as previously described. So that's what that's for. Going through our 10k log pot as the master volume control, into this non-inverting op amp stage, featuring a 1k5 feedback resistor and a 1k5 gain resistor, and using the formula gain equals 1 plus resistive feedback divided by a resistive gain. That gives us a gain of 2. So if we had, say, forgetting that this also adds gain, but if we had a gain of 8 volt at this input, well, that means now we've got a gain of 2, so 8 volt here equals 16 volt there, in a theoretical world. So basically what I'm going to do is I'm going to build up just the bass section here, which features a, well, this should be marked as 100k linear for these pots, but they're not, but we'll just say for sake of argument they are. Just this pot in that op amp, and then build this output stage, and then we'll have a look at some stuff on the scope there just to see, say, our line level input of 2 volt. That means we have 8 volt after the mixer if we have 16 volt at the output of the buffer. So let's get cracking. Lollipop, lollipop, oh lolly, 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 lollipop, lollipop, oh lolly, 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 lollipop. Ba-dum-bum-bum. Anyway, a little time later, probably about 45 minutes, because I was busy messing around doing other little things in the background here. I've got the circuit built up, and it looks like Frankenstein's penis with all these capacitors and resistors and wires everywhere. The bass pot, I took a shortcut. I actually just wired the required components to the pot leads. The 3 resistors just poke into various different places in the breadboard. Got the master pot wired in. Now my choice of op amp for the output buffer is an NE5534 single op amp, which just has a slightly different pin out to the dual counterpart, but that will be referenced on the schematic anyway when I finally draw it up properly. So I've basically got the base pot as the back sandal circuit, and I've got the NE5534 as the output buffer. I had this 22k resistor on the wrong side of this input cap, so it was starting to flat bottom or unsymmetrically clip and start falling off, and that's the reason why, because the capacitor was now in the path of this resistor, which is supposed to be biasing the input pin of the non-inverting input of that op amp correctly, which it was not. Anyhow, I sorted that out, and I've already tested it off camera just to make sure that everything's working and wired correctly, so I'm not wasting time on camera. So today I'm going to use the big boy's oscilloscope, and I've got both the line input volume control up full and the master volume control up full. We've got a 2 volt 1 kilohertz signal going into that particular mixing stage, and I'm going to turn the power on, and we can see we've got a nice unclipped waveform. So this is with the volume controls at maximum and there's no clipping. And we're pushing out, close to what I was expecting, a healthy 17.2 volt peak to peak. So if I rotate the high gain input pot up, that's the one that was the guitar amplifier, well, the guitar input, we can see that the waveform as it's mixing gets noisy, and in actual fact it looks like it's just started oscillating. That's the input. So if I touch the input lead, the oscillation goes away. But yeah, that looks like to me like it's oscillating. Pretty bad there. So I'd actually have to look at that output separately, but I'll look at that in a sec. Again, that's because of the wiring of the breadboard, but if I rotate the base pot, we can see little to no effect on our output waveform. So if I select a frequency such as 60 Hertz, when I can see what I'm doing, 60 Hertz, right, and then adjust the time base to 10 milliseconds per division, which is there. Oh, yep. We can see we've got a 60 Hertz signal there. Quite a little bit less output voltage at that frequency. So I rotate the base pot, and we've got a significant increase, but we still do not have clipping. And we're pushing close to 23 volt peak to peak out. Not bad. So I'll cut the base, so decrease the pot. And it didn't completely cut it all the way, but we've now got an output voltage of 8.4. That's at 60 Hertz. So if I went to say a frequency of 100 Hertz, the actual amplitude is a lot higher at cut. And if I rotate base pot full, it's a lot less at full clockwise rotation. We're only around about 19.7 volt. So if I now go to a frequency of 150 Hertz, it increased probably by a volt. So we're at about 18.1. That's full boost, full cut. It's starting to not really affect it too much. That's 13 volt peak to peak. So if I go to 20 Hertz, which we now can't see very well, although that waveform will do, boost, we have got 22.7, and full cut, we've got nearly nothing. We've got 1.8. So yeah, it's reactive points around the 20 Hertz range, which is okay. And I would say the cutoff is around 500 Hertz, which is what I'm going to select now. And we'll drop our time base down to 5 milliseconds per division. And I'll rotate the base part. Absolutely no change. Back to center, we're still at 16.9. Full boost, still 16.9. Full cut. Absolutely no change. Probably all of about 300 millivolt. We're at 16.3. 16.3 at center. 16.9 at boost. Yeah, so it changes by about 600 millivolt. So yeah, the center frequency of that base pot is 500 Hertz. Brilliante! Alright, well I've messed around with the input stage a little bit further, and I have now stopped the guitar input, which was the highest gain, well the microphone's the highest gain, from oscillating too badly, but I set it to a range of 500 millivolt. So that's when you're touching the input lead and it's not causing an oscillation. I've also set up a channel for 1 volt peak to peak in for line as well. That's all done. And we're getting roughly 20 volt out peak to peak of the preamp, which is good. As for the microphone, yeah, well, we'll get to that a little bit later, but so far the entire circuit seems to be functioning. So whilst I'm on this line input, we'll just have a look, just for the sake of it, at a sweep on the output. I think I already did this in the last video, but it's remaining consistently around 22 volt roughly peak to peak through the frequency range. So that's pretty good. So that means that that is now functioning correctly, as a preamplifier should be functioning. Yeah, so next step is to probably hook it back up to the power amplifier and output it. Okay, so I've got 2 channels of the oscilloscope hooked up now, and I just want to prove a point. For some reason channel 1 doesn't show the waveform inverting or non-inverting depending on where it's measuring the circuit. I don't know why. It doesn't switch the waveform around, so it always looks like this. But if I look at the output of the preamp here, now take note of the polarity. We're ignoring this. This is just probing another output at the moment. That's actually probing the output of the summing amplifier. So we can see that what phase it's in. Now if I probe the input, we can see it's exactly the same. It's in the same phase. So if I was to like change that to inverted there so we can actually see what it looks like. So that's the normal waveform input. And I've got the probe stuck in the pot. And I probe set output of the preamp back to times 10. We can see, if it would stay there, we could see the output is exactly the same phase. If we now probe the output of the summing amplifier, we can now see that it is inverted. It's too big. So we've got 180 degrees out of phase there, which is then corrected at the output 180 degrees back in phase. And that's responsible because of the back sandal. So if I go to the output of the back sandal, again we've got the same output in the correct phase. Alright, got the power amplifier hooked up now. Got the input gains down low and the master down low. No noise. There's nothing connected to the inputs yet. Just making sure and verifying that things are working. I've got a bunch of short circuits here. That one's giving me an output. This one is not. That's because the fucking leads come out. There we go. Okay. Alright, I suppose I better hook it up to a source of input, eh? Okay, got the CD player hooked up to the 1 volt input. It's not 2 volt anymore. Doesn't really matter for this test. Turn the volume down. And I'll hit play. Okay. Okay. Well, the bass pot is doing something. I think this Class A is distorting early. Actually, I know why the bass pot's not working as it should. I've got a 220 nanofarad across there instead of a 22 nanofarad. Oh well, that doesn't make much difference really. Well, it does. I was wondering why the bass response was pretty crap, and that's... I've put a 0.22 microfarad across my bass pot instead of a 0.022 microfarad. Oh dear, oh dear. Oh, I fucked that up again. Oh well, I mean, I'll get it right in the final design and everything. So we can now ignore the tests for the bass pot on the oscilloscope because they're going to be completely wrong. It's having very little to no effect on the 100 Hertz range as we saw on the oscilloscope, and I didn't twig then as to why. I have now. Anyhow, that's beside the point. Point is, it does work, and it seems to work reasonably well. Yeah, I'm probably about 10 o'clock on the line input one, and about 12 o'clock on the master out. But as I say, I think the Class A module is clipping early, so it's not really going to provide me shitloads of gain. But anyway, it's time for a bass guitar test on the 500 millivolt input sensitivity range. Ignore the buzz. That again is circuit noise. So here we go. had that track in a while. It's actually just a practice bass track for slapping. I don't have that track anymore. I'll just turn the camera on myself so you can see what I'm doing. Okay, so in conclusion, I actually switched to the desktop speaker there. The preamplifier is pretty much well designed for the most part. I was thinking of adding a balanced line output driver to it, but yeah, for my purposes I don't see the need. But leave a comment below if you want to see the expansion of this to using a balanced output for line before the potentiometer here. And other than that, if you like this video, please remember to rate, comment and subscribe below, and you can always follow me on Facebook and Twitter. The links are in the description as usual. Anyhow, this is the Abstract there saying, see ya, thanks for watching.